Okay, so I'm talking about how to use the graph of a derivative to solve certain problems in calculus. So the first problem, let f be a function defined on the closed interval -7 to 5 with f of 2 equal to 3. The graph of the derivative of f is provided and it consists of some line segments and a semicircle as shown on the left. So the first thing we need to do is find f of -6. So using the first fundamental theorem of calculus, the integral of -6 to 2 f prime of x dx equals f of 2 minus f of -6. It's just the first fundamental theorem. And then if you rearrange that to get f of -6, it equals f of 2 minus the integral from -6 to 2, f prime of x dx. Now to plug in values. So it gives you in the problem f of 2 equals 3. So we plug in 3 easily. And then to find the values for the integral, you just look at the areas under the curve from the lower bound to the upper bound. So -1.5 minus 6 plus pi over 2 minus 4.5 plus 2. And you plug that in for the integral of -6 to 2 f prime of x dx. And when you simplify that out, you get f of -6 equals 13 minus pi over 2. And then the next problem is to find f prime of 1. It's very simple. The graph is of f prime, so you just need to look at 1. And at f prime of 1, that is equal to 1. So it's the same graph. Now we need to find the average value of f prime on -6 to 5. So using the average value formula, which is f of c equals 1 over b minus a, the integral of a to b, f prime of x dx. If you plug in values, you get f of c equals 1 over 5 minus -6 times the integral of -6 to 5, f prime of x dx. And then again, using the areas under the curve of the graph, you get -1.5 minus 6 plus pi over 2 minus 4.5 plus 2 plus 1 minus 4 all over 11 because 5 minus -6 equals 11. And then when you simplify that, you get f of c equals -13 plus pi over 2 over 11. And then to avoid a complex fraction, you get the average value is -26 plus pi over 22. Now for the next problem, we have to find the integral from -3 to 2 of f double prime of x dx. So we use the first fundamental theorem of calculus here. The integral from -3 to 2 f double prime of x dx equals f prime of 2 minus f prime of -3. And if you just have to look on the graph for those values, so f prime of 2 is equal to 2, and f prime of -3 is equal to -3. So that becomes 2 plus 3, so the integral of -3 to 2 of f double prime of x dx equals 5. Now with the same problem, a different graph and a different part of it though. Let f be a function defined on the closed interval -9 to 9. The graph of f is shown above. Let g be the function g of x equals the integral from -5 to x f of t dt. The first thing we need to do is find g prime of 3. So to do that, g prime of x is equal to the derivative in respect to x of the integral of -5 to x f of t dt, and that also happens to equal f of x. So therefore you have g prime of x equals f of x, and so g prime of 3 equals f of 3, and with the graph of f being shown, g prime of 3 equals -1. For the next part, you have to find g of 5. So using the equation it gives you, g of 5 equals the integral from -5 to 5 of f of t dt. And so then that would equal the areas under the curve of the graph once again, because that's how you find an integral. So g of 5 equals -5 minus 6 minus 9 over 2 pi minus 4. And so that's the integral. So g5 equals -5 minus 6 minus 9 pi over 2 minus 4. And when you simplify that, g of 5 equals -15 minus 9 pi over 2. So for the last problem, you have to find the average rate of change of g of x on -9 to 5. So for that, you have to do g of 5 minus g of -9 over 5 minus -9, which is slope. And so we already found g of 5, which was -15 minus 9 pi over 2. So then that's minus g of -9 over 5 minus -9. So we need to find g of -9. So to do that, use the equation it gives you. So g of -9 equals the integral from -5 to -9 f of x dx. And then so you can have the bounds in the right order, you flip the sign, so it would be negative integral of -9 to -5 f of x dx. And so g of -9 equals, using the areas under the curve, the negative quantity of 4 minus 4, which is just equal to 0. So your average rate of change will be negative 15 minus pi over 2 minus 4 over 5 plus 9, or minus 0 over 5 plus 9. And simplifying that, just get rid of the 0, which is negative 15 minus 9 pi over 2 over 14. And then, so it's not a complex fraction, you have that equal to negative 30 minus 9 pi over 28. And that's how you solve problems using the graph of a derivative.